Hello students, welcome back. Today we stand on the fourth step of a journey with algebraic expression, and this is the last phase of the chapter. So let's begin with the last topic of the chapter, and what is that? That is standard identities or algebraic identities. Now students, before coming to identity, let me explain what is an equation. We did x plus 5, that's an expression. Anything you write, 2x plus 3, that's an expression. Algebraic expression, because we are taking number as well as literal, 2x plus 5 is an algebraic expression. The moment I write, say for instance, x plus 5 equals to 8. That becomes an equation. Why? Because I am equating the left side with the right side. So x plus 5 equals to 8. So when I write x plus 5 equals to 8, what is my x? My x is 3. So only it will be true when my x is 3. Then x plus 5 will be 8. So this is called an equation. It will be true for only few literals, not all. Then what do you mean by identity? Identity is an expression which will be true for all literals. Whatever value you put for the literal, your equation will be true. That is called an identity. So what do you mean by standard identity? Standard identity means it is an equality. It is an equality. This equals to this. So it is an equality which is true for all values. Which is true for all values of the variables. Whatever you put the value, your identity will be the same. The identity of the expression, it will come the same. So in algebra, you have few such identities, and these are called standard identities. We begin with the first identity. You come to the first identity is a plus b whole square. The first identity, a plus b whole square. Now students, what do you mean by a plus b whole square? We have already done multiplication with algebraic expressions. A plus b whole square means a plus b into a plus b. So with a you multiply both, with b you multiply both. After multiplication, what will you get? You will get a square plus 2ab plus b square. So a plus b whole square equals to a square plus 2ab plus b square. Similarly, when you do a minus b whole square, that is a minus b into a minus b, you will get a square minus 2ab plus b square. So whatever you put here the value, 2 plus 3, 5 plus 6, 8 plus 9, you will always get a square plus 2ab plus b square. And that is why this is an identity. We call it standard identity. It will be true whatever is the value of the variable. Next we come to a plus b, a minus b. So when you do a plus b, a minus b, what will you get? A square minus b square. The third identity. The last one, the fourth identity, here in class 8, you will be dealing with only 4 standard identities. So the last one, x plus a into x plus b. X plus a into x plus b, what will you get? X square plus a plus b into x plus ab. Now students, you don't have to learn this. There is nothing to memorize. As you solve sums, automatically this will be there in your mind. By chance if you forget, you do the multiplication, you will get back the identity. So all 4 identities, children. The first one, a plus b whole square, what we get? A square plus 2ab plus b square. A minus b whole square, a square minus 2ab plus b square. The third identity, a plus b, a minus b. What we get? A square minus b square. And the fourth, the last identity, x plus a into x plus b. You can see only the first factor is same here. The second factor of this and the second factor of that one is different. What will be the identity after solving? You will get x square plus a plus b into x plus ab. So in exercise 10.5 students, in exercise exercise 10.5, we will be solving sums with these identities. You have to apply the identity. You have to write that using this identity I am solving this particular sum, and we shall follow that particular identity and we shall solve it. Let us come to the first question of exercise 10.5. As you come to the first question, children, your question is 3x plus 5 into 3x plus 5, and the question says using suitable identities find the following product. You just cannot do that. Students ask me very often that, Miss, I can straight away do 3x into this and this, 5 into this and this, and can solve? No. You can do simple multiplication only if the question is find the product. Then straight away you will do multiplication. But when the question itself says that you have to apply identity and solve, then you have to solve it in that particular manner. Be very careful. You cannot straight away go here multiplication. You cannot start up with. You have to mention that utilizing which particular standard identity you are solving this sum. Why? Because your question says using suitable identities find the product. Now as you come to the question here, 3x plus 5 into 3x plus 5, I come to the solution, children. So using the identity, which identity I am using here? You can see a plus b, a plus b. See the first identity. So using the identity a plus b whole square, and that is equal to a square plus 2ab plus b square. Followed? Now here straight away, then what is my a? My a is 3x. Children, my a is 3x. What is my b? My b is 5. My b is 5. My a is 3x. You have to be very particular. Now the first is a square. This is your a and this is your b. So a square means 3x whole square plus 2ab means 2 into a into b. So 2 into a means 2 into 3x into b. b here is 5. So into 5. The next step, plus here 3x square plus 2 into a into b plus b square. What is my b? My b is 5. So plus 5 whole square. What we get? Here the common silly mistake is what students do, 3x whole square, they write 3x square. That is the common mistake. Students, be very careful. 3x whole square. That means you have to do 3 square as well as x square. So you have to be very careful. 3x whole square means 3 square is 9, 9x square plus 2 into 3 into 5. 5 2s are 10, 10 3s are 30. So plus 30x plus 5 square 25. See the sum. So your answer is 9x square plus 30x plus 25. That's your answer. This is the first question. Question number 1. Now we come to the second question. Question 2. 2, 1 you see the question the same using the identities you evaluate. Question number, sorry, this is question 1 itself. Question number 1, the second question I am doing. Question number 1, the second question. That is 9y minus, question number 1, the second question. 9y minus 5 into 9y minus 5. So you can see here a minus b, a minus b. So which identity I am using? Using the identity, which one, students? By seeing here, using the identity a minus b into a minus b. That means a minus b whole square, and a minus b whole square equals to a square minus 2ab plus b square. So now I have to solve it. I have to solve it with that particular identity, that is a square minus 2ab plus b square. 9y, that is my a, and 5, that is my b. So that is equal to a square. My a is 9y, so 9y whole square minus, be very careful, a minus b whole square equals to a square minus 2ab plus b square. So a square minus 2 into a, 9y, into b, 5, plus b whole square. What is my b? 5. So 5 whole square. That is equal to 9 square. 9 nines are 81. 81y square minus number into number. 2 into 9 into 5. Always make the multiplication easier by doing the tens or the multiples of tens first. 5 twos are 10. 10 nines are 90. So minus 90y plus 25. So that's the answer. This is question number 1. The second one, 81y square minus 90y plus 25. So which one I solved? I solved both the questions of question number 1. That is question number 1, the first one, and then I did question number 1, the second one. If you come to question number 1, the third question, the question is children 4x plus 11y into 4x minus 11y. Which identity I am going to use? A plus b, a minus b. So a plus b, a minus b, that is equal to a square minus b square. So question number 3, you will be utilizing the identity, that is a square minus b square. So what you have to do, you have to see the question very carefully. After seeing the question, you have to think which identity this will follow. Which identity will I apply to solve this? Write down the identity and solve accordingly. So now students, the next question, that is question number 2. Now students, we come to the next question, that is question number 2, using the identities and evaluate. So here children, you can see your question is 81 whole square. Now you may wonder, how can I apply an identity a plus b or a minus b where my question is 81? Now here what you have to do is children, you have to break it. Break 81 in such a way so that you can apply the identity. You can break it as 40 plus 41. You say, miss, I can break it as 90 minus 9. No, you will not break it in such way. You will always try to break it in terms of 10, like in terms of 10 or multiples of 10, like 100 or 1. Why? Because square of these numbers is easier to solve. You can solve the square easily. So 81 children, I break it as 80 plus 1 whole square. So which identity I am going to use? Using the identity a plus b whole square. So a plus b whole square equals to a square plus 2ab plus b square. So let us solve. So this will be equal to 80 whole square plus 2 into a into b plus b whole square. So 80 square, 80 into 80, 80 is 64 and 2 zeros plus 2 into 80, 2 8s are 16, 160 plus 1. So what is my answer you solve? 6400 plus 160 plus 1. So 1, 6, 5 and 6. So my answer is 6561. That is the answer. 6561. Now you come to the second question. The second question is 97 whole square. How can you break 97? Very easy, with the term of 100. So 97 solution equals to 100 minus 3 whole square. So the moment you write students 100 minus 3, that means which identity you can apply? You can apply a minus b whole square equals to a square minus 2ab plus b square and solve that. Now you come to the next question, that is question number 4. Question number 4 is, they have given you the identity that you have to apply the identity x plus a into x plus b. And what is your question? X plus 7 into x plus 3. Using the identity, let us solve. So that is equal to x square plus a plus b. So 7 plus 3x plus ab. So 7 into 3. Now let us solve using that particular identity children. Here my x is x and what is my a? 7. What is my b? 3. Followed? So solve it. X whole square, x square plus 7 plus 3. That means what? 10. 10x plus 7 3s are 21. So answer x square plus 10x plus x square plus 10x plus 21. Followed? If you come to the next question, that is question number 5. Question number 5 is same as this. Evaluate. Question number 5, the question says using the identity. Identity is given here. You have to apply. How can I apply this identity? I have to break the number in such a way so that I can apply x plus a into x plus b. So 203 and 204, very easy. What it will be? 200 plus 3, 200 plus 4. So 200 plus 3 into 200 plus 4. So as you break it, you apply x plus a into x plus b and solve this question. So students, with this we come to the end of today's class. What we did today, we started with standard identities, and how many identities we solved? We solved questions on 4 identities. So thank you children, goodbye and good luck. Bye bye.